In our code, we will be determining the permeability of a rock sample using given experimental data and values. The equations we will use are Darcy's law, which determines permeability, as well as those shown as followed. First, we inputted all the given values and entered the flow rate setting dataset into a matrix. The matrix will be entered into a data validation loop, which will determine whether or not the value is in range. If not, the user will be given a warning and be asked to input a replacement value. If the user fails to enter a correct value, the error will output. The values we entered are the replacement values used in our code. We will also determine the average values for temperature and pressure drop of each setting and convert needed values. We will use volume divided by average time to determine flow rate. For task 2, we will input our converted values to find the permeability and average permeability of the flow rate. For task 3, we will perform error calculations and other calculations to find resolution uncertainty, standard deviation, combined uncertainty, and error propagation. The command window outputs two figures. Figure 1 shows the relationship between permeability and flow rate setting. As you can see, setting 5 yields the greatest permeability, while setting 11 yields the lowest. Before we plot for the second graph, we converted the given values into pressure. Before we plotted the second graph, we converted the units from dynes per centimeter to atmosphere. For figure 2, we plotted average flow rate against average pressure. A trend line is also added to show linearity of the relationship. Along with the two figures, the final output consists of the average permeabilities and errors of each setting as well as the overall rock.